Hi, and welcome to a lesson on refinancing and mortgages. As you're well aware, money does not grow on trees, and houses don't grow on money either. If you want to buy that nice house and live the American dream, unfortunately you're going to have to fork over quite a bit of money. For most people, forking it over at the time you purchase the house is an impossibility. That's when people take out what's called a mortgage. The expectation is that the mortgage will be paid in full over a time period of 15 to 30 years, and the interest associated with it must also get paid off. Tonight we're going to look at Pat and Sam's mortgage from a previous class as an introduction to mortgages and refinancing. So, if you'll recall, in a previous lecture, Pat and Sam borrowed $300,000 at a 6% annual interest rate. We calculated that their monthly payment had to be $1,798.65. Let's focus in on a specific point in time during their mortgage payment. Suppose that they had already been making mortgage payments for 8 years. How much do they still owe with 22 years left? If you recall our amortization table, if Pat and Sam have been paying for 8 years, I'd like you to stop and think about specifically where in the amortization table would they be? Which payment number would that correspond to? If you guessed 96, your answer was correct. Pat and Sam have been making monthly payments, 12 of them per year, for 8 years. So they're at this point right here, $263,317.26 still owed. That's quite a bit of money, considering they're almost a third of the way through paying off the mortgage. Unfortunately, they're not a third of the way through, money-wise, paying off the principal. So let's take a look at why this is. Why do they still have so much money left to repay? We can use Annie to determine exactly how much is left with 22 years remaining. To do that, we'll calculate our periodic interest rate, much like we did previously. We'll take our 0.06 and divide it by 12, giving us an I value of 0.005. The N value is a bit different. We are making monthly payments, but we have 22 years left. So we're not going to multiply by 30 this time, but 22. And that means we have to make a total of 264 payments until the end. If you forgot the Annie formula, here it is again. I'd like you to take out your calculators and calculate the value of Annie with me. Like we did in class, we want to do the numerator first to ensure that we don't make any careless calculator mistakes. So I'm going to type in the numerator and then I'm going to divide by the denominator. Recall, for the denominator we want to use parentheses since we have a product in the denominator. The calculator doesn't understand if you don't use it. It takes the order of operations as they appear on the calculator. So we want to have those parentheses and we can divide appropriately to obtain an Annie value of 146.3969265 ... So on my paper, I'm going to record the first couple digits of Annie as they appeared on my screen, but I'm not going to erase them on my screen. I'm going to go back to the calculator screen and multiply it by the payment. And we see that Pat and Sam still have about $263,316.83 left to pay off on their mortgage with 22 years remaining. You might observe that this value is slightly different from the one in the amortization table. We're off by a couple cents, but That's because of the rounding that takes place on the spreadsheet. Let's take a look at question 1b. Suppose that by the time 8 years have passed since Pat and Sam bought their house, mortgage rates have dropped to 4.8% for a 22-year mortgage. Imagine that they owe Bank A the amount we just calculated, and now they can borrow this very amount from Bank B at a lower rate of 4.8%. Pay back Bank A in full, and just be in debt to Bank B at the lower rate. If Pat and Sam refinance in this way by taking out a 22-year mortgage at the lower rate so that they will be done paying off the house at the same time as with their current mortgage at Bank A, what will their new monthly payment be? Refinancing means that you pay off existing debt by taking out a new loan and using the new loan to borrow the amount needed to pay the old one off. So here Pat and Sam are being very intelligent. They're going to take advantage of a great offer to pay off the original big loan that they had. To figure out their new monthly payment, we can use the same formula as we did before. Present value equals PMT times Annie, where Annie is a subscript. So we can use the remaining balance as our present value, $263,316.83. We want to figure out what payment monthly is required to meet this goal. Annie is going to be calculated in a similar manner as before. However, this time for Annie, the interest rate is going to be 0.048 divided by 12. We're going to take advantage of a new rate, or more simply put, 0.0404. The value of n still stays the same because we still have 22 years ahead of us, so n will remain the same at 264. Once again, we can use our calculators to determine the value of Annie with this new information. So we'll take 1 plus 0.004, raise it to the 264th power, subtract 1, then divide by 0.004 times 1 plus 0.004 to the 264th power. The value of Annie this time is much larger at 162.8555312 ... So I will take that and write it down, or type it down, since we're in cyberspace this evening. And to calculate PMT, we divide both sides by Annie. So I'm going to go back to my calculator, and I'll leave the unrounded value on screen. I'll take my present value, I'm going to divide it by Annie. And I can reference the value just computed by hitting second and the negative sign. So it appears that our new monthly payment will be $1,616.87. Now, if you compare the payment in option 1B versus the monthly payment in option 1A, we see that the difference in monthly payments is a little bit over $100. In fact, closer to $200. Might not seem like a whole lot, but if you examine saving that amount of money over all 264 payments, you can save yourself quite a bit of cash. And that's what we're going to look at in part C. So in part C, by refinancing, how much will they save over the next 22 years in interest? On each payment, they are saving the difference between the higher payment and the lower one, which is $181.78. Over the course of 264 payments, they are saving 264 times that very same $181.78, which means they save a whopping $47,989.92. They can buy their midlife crisis car with that kind of money. Since the total principal they repay in each case is the same, regardless of the loan they take out and the interest rate associated with it, they still have to pay the same amount back in principal. The difference of $47,989.92 is entirely interest.